The assignment that we have for this week will require that you perform a paired samples t-test. A paired samples t-test assumes that you are working with the same group over a period of time or separated by a context. So over a period of time could be a pre-test and a post-test. Students that come into your classroom, you test them on their math skills at the beginning of the semester, you teach them for a semester and you test them on the same skills at the end of the semester, and you compare the two scores to see if there has been a difference in learning over time. Context could be such as the experiment that the data file that we have for Big Hairy Spider suggests. So they're not separated by time but by context. So you have a group of participants that are looking at pictures of spiders. By the way, these are arachnophobes, people who are afraid or have a phobia of spiders. And the other context is playing with real spiders. And the question is there a difference in the anxiety rating of the arachnophobes within these two different contexts? To perform this analysis, you will click on Analyze. You will compare means, look for paired samples t-test, and in this case, you will be bringing in the variable 1, picture of spider, and for variable 2, real spider. You only have one pair, you don't have two, so you would end at about this point. For options, you have nothing to worry about and simply click on OK. So for the paired samples t-test, when looking at a picture of spiders, the mean was 39.82 for the 28 participants, with a standard deviation of 9.37. For the real spider, the mean was 46.18. So eyeballing this, not necessarily analyzing statistically, we could assume that there is a difference. However, the statistically significant differences don't depend simply on the mean, but depend on the sample size and on variance or variation, and the standard deviation as well, and so forth. And so when we look at the paired samples correlations, is there a correlation? This could be considered a small correlation between the two. This is not a significant correlation. The picture of the spider versus a real spider, the mean difference is 6, the standard deviation is 12.70, the standard error of the mean is 2.4. The t-statistic, which is what I'm concerned with, is negative 2.64. Don't worry about the negative sign. The degrees of freedom are 27. This is, again, even though it appears to be two groups, this is the same group tested twice, so the degrees of freedom are 27. And this difference is statistically significant at the 0.05 level with a significance or probability of 0.013. And that would be the paired samples t-test.